Okay, unit circle part 3. We've made some pretty good progress. We identified how we could find the sine and the cosine of various angles around the unit circle using special triangles, and also just using the coordinates that are on the x and the y axis. But we'd like to be able to know the sine and the cosine of more angles other than just 30 and 0 and 90 and 180 and 270. So we're going to take a look now at how to figure out the sine and cosine for 45 and then 60 degrees. So for 45 degrees, again, we make a line. Oh, that's a horrible line. Oh, that's better. Okay, so we make a line that goes about 45 degrees, and we'll label that as such, 45 degrees. Again, we're mainly concerned about the central angle, not the angle out here. And then what we do is we draw a horizontal and a vertical line. And the reason for the horizontal and the vertical line, the vertical line, the length of it is the sine of this angle, and the horizontal line is the cosine of this angle. So this guy right over here, the length of this is going to be the cosine of 45 degrees. That's the length. And the height of this is going to be the sine of 45 degrees. And we can verify that with our calculator, but first we got to figure out what those values are. I apologize, I don't have room to put arrows here, but there we go. That length is cosine of 45 degrees. So we'll start off with this idea that the unit circle has a radius of 1. So we know the length of the hypotenuse. And we'll go back to our old friend, the 45, 45, 90 special triangle. We know that the relationship between the sides is like 1, 1, and square root of 2. We figured that out using Pythagorean theorem. So the only problem is that the hypotenuse here is square root of 2 and the hypotenuse here is 1. And the way we fix that to make them both the same is we'll go and we'll divide this by square root of 2, and we'll divide this by square root of 2, and we'll divide this by square root of 2. So it turns out that the length of So what I'm trying to say with all this talk about these sides, this 45, 45, 90 triangle, is that this side right here, if we have a 1 up here for the hypotenuse, then this side will be 1 over square root of 2, and this side will be 1 over square root of 2. And that means this cosine of 45 right here, it must be equal to 1 over square root of 2. That must be the length. If we believe that in this unit circle the radius is 1, then the length of cosine of 45 degrees, the distance from here to here, must be 1 over square root of 2. And it turns out the same happens to be true for sine of 45 because this side and this side are equal. So it's also 1 over square root of 2. And again, you'll remember that we have this fancy thing that we do when we have a radical in the denominator. Sometimes we rationalize the denominator. We'll multiply by square root of 2 over square root of 2. And when we do, we get square root of 2 over 2. So I will expect you folks to know that the cosine of 45 is either equal to 1 over square root of 2 or square root of 2 over 2, since these guys are both equivalent. So let's make sure we add that to the notes as well. Now, with this idea in mind, I'm going to write it down here if you don't mind. With this idea, what we can say is this, is that when we're looking at this point right here on the unit circle, that point at 45 degrees from the horizontal is going to have a cosine of square root of 2 over 2 and a sine of square root of 2 over 2. And we can verify this with the calculator. If we go and look at 45 degrees and we take the cosine, we get 0.707. And if we take 45 degrees and we take the sine, we get 0.707. And we'll just go and we'll verify that if we take 2 and we take the square root and we divide by 2, square root of 2 over 2, we get 0.707. Again, it's worthwhile for you to try this on your own calculator, but the main point that I'm trying to make here is this, is that when we're on the unit circle, the x coordinate on the unit circle is the cosine of this angle, and the y coordinate of this point is the sine. This is the sine of this angle. So again, let's write it out so we can be very explicit about this. We're going to say that the cosine of 45 degrees is equal to square root of 2 over 2, and we get that from here. And the sine of 45 degrees is also equal to square root of 2 over 2, and we get that from right here. All right, hopefully you folks are with me. Now we have more to do, but I at least want to give you guys the 30, 60, 90 and the 45, 45, 90. We still have a little bit more to go.